Hi, in this tutorial, we're going to be writing a very simple smart contract in SmartPy and React. For the first part of this tutorial, we're going to be using SmartPy, which is a smart contract programming language for the Tezos blockchain. First, we're going to navigate to smartpy.io/IDE. This allows us to write our SmartPy code right inside the browser. Now we're going to import SmartPy as SP, basically tapping into the SmartPy library. And we're going to use the decorator sp.module so that our code understands that the next block of code is actually going to be a SmartPy module. Then we call the main method, and we initialize the class voting. And voting class is going to inherit from the contract class of SmartPy. Then we start off with our init method, and our init method is going to take two parameters, players and voters' wallet addresses. Players is going to contain a list of players that you can vote for, and voters' wallet addresses is going to contain a list of wallet addresses of people who have already voted within our application. Then we're going to cast the wallet addresses to a set. This way, by ensuring that we cast a type, we can ensure that users of our application cannot just pass whatever type of variable that they want to pass in here. We can actually control the type and make sure that they are always a valid wallet address. Next, we define our storage. Storage is almost like your database, and it is where we keep the stores of value of things that we want to be able to update. The first one that we're going to call is self.data.players, and it's going to take a parameter of players. Next, we're going to call self.data.voters wallet addresses, which is going to take a parameter of voters wallet addresses. Then we're going to call self.data.dummy, which is simply just an empty string. Now we start to define our entry point. In SmartPy, to define an entry point, you use the decorator smartpy.entryPoint or sp.entryPoint, since we've already renamed SmartPy to sp here. And then we call our first method, which is increase votes. Increase votes is going to take two parameters, self and params. Self is simply the instance of this smart contract that we're writing, and params would contain any other variable that we want to pass to our method. Now the first step is to check if this user has already voted previously. If the user has voted previously, we're going to throw an exception and return the error you already voted. As you can see, we're leveraging SmartPy's .sender method here to do this check. Next, we're going to pass in a player ID as well for the player. So if the player is not found in our storage, we're going to throw an error, player ID not found. Now, once we're able to get through our assertions, we can start to actually write our logic. Now, the first step to writing our logic is to increase the votes for the player. So we're going to search using the player ID, which is coming from params. And once we can find the player ID within params, we're going to call the votes method on it, and we're going to increase it by 1. Next, we're going to call self.data.voters wallet addresses.add, and this will allow us to add to our set up here the user's wallet address who has casted their votes. We're going to also define another entry point, which is simply just a dummy entry point, just to make sure that we have more than one entry point in our smart contract. Now, for every smart contract, we need to write tests. And the first step to doing that is by using the decorator sp.addTest. We're going to give the test a name, and usually you give the test the same name as your class. We call the test method, and then we define a list of test accounts. For our test, we can simply call the smartpy.testAccount method and pass a name to this method, and it would give us an instance of a test account. Now we need to define a scenario. So a scenario is simply tapping into the main class and ensuring that we can actually use the main class to run certain tests and create certain scenarios. Then we define a record of players. So right here you can see we've got 5 players. They've each got a name, they've got a year, and they've got votes. Like I said up here, when we call the increase votes method, we're going to be able to increase the number of votes here by 1. And as you can see, we've defined that down here as well. So while vote is initialized to 0, when we get up here inside our increase votes entry point, we can always increase it by 1 in here. We can initialize our contract by calling contract equals main.voting. And this would essentially allow us to pass in our record of players so that we can have a list of players in our storage. And then we can also pass in one wallet address when instantiating our contract. And the way to do that is simply by calling the sp.set, and you pass Alice's address. Alice is already initialized up here, and we simply pass our address in here. Now, we can start to create a scenario by feeding the contract into the scenario. Our first scenario would be to test whether the votes actually increases when we pass the right player ID. And as you can see here, we call the increased votes entry point. We pass in a player ID, and we tell our test that the person sending this transaction is Bob. And we also pass Bob's wallet address in there. And then we call the scenario.verify, which allows us to verify that our test is true. So we check whether the player with player ID 2, whether their votes increases by 1. And then we create a new scenario again to test, just to make sure that what we've tested here actually works correctly. So again, we call player ID 2, we increase their votes by 1, and we check that their votes count is now 2. Now, if the user has already voted, we want to be able to check that we are getting the correct error. And as you can see here, we increase the votes again for player ID 2. And this time around, we pass Charlie's wallet address. As you can see, we've already passed Charlie's wallet address up here. And we're passing Charlie again in here. Now, we're going to get an exception that you've already voted because Charlie has voted previously. So that should throw an error just like we've defined in our increased votes entry point. And lastly, we're going to do another test. If the player ID does not exist, we want to make sure that our smart contract throws an error. And once again, we pass a sender. And then if the player ID does not exist, as you can see, we have player ID 6 here, but we've only got 5 player IDs in here. So this should also throw an error. Now, once you're done going through all of these steps, it's time to get to the fun part, which is running our smart contract. Simply hit the run button within the SmartPy IDE, and that's going to show you something to the right. So as you can see here on the right, our first test runs. We increase the vote of player 2. Player 2 is Erling Haaland. And you can see that his vote count has increased by 1. Now, let's go to scenario 2. We should see that Erling Haaland's votes should now be 2. And if we scroll down, we can see that Erling Haaland's vote has gone up to 2. So our tests work correctly. The next scenario that we're testing for is that if the user has already voted, we should be able to ensure that we throw an error saying you've already voted. And if you check in here, when we pass player ID 2 and the sender of the transaction is Charlie, who already sent a transaction previously, we're going to get an error saying you already voted. And lastly, when we pass a player ID that does not exist, player ID 6, we should get a player ID not found error. And that is exactly what happens here. Now, with all our tests done, we are ready to deploy our smart contract to the Tezos blockchain. On Tezos, when you write your smart contract using any of the smart contract programming language, for example, SmartPy, like we're using in this example, the code is compiled down to Michelson. And to do that, simply click on Deploy Michelson Contract. So now we're going to be originating our contract to the blockchain. And we're going to click on Deploy Michelson Contract again. We're going to select the Ghostnet, and we're going to select an account. I already have a Temple wallet set up, so I'm going to be using a Temple wallet for this example. Click on Temple. It's going to pop up this screen where I can enter my password and get into my wallet. And I'm going to connect one of my accounts to this transaction. So I'm going to pick account 6. So click on Validate. If you're doing this for the first time, you're going to need to review your account before you can do this. So you're going to see a Reveal Account button on the screen. Hit that Reveal Account button and then click Validate. Next, click on Estimate Cost from RPC. Then hit your Deploy Contract button. Click Accept and sign the transaction. And just like that, our smart contract has been deployed to the blockchain. Now on Tezos, we usually need 2 block confirmations for us to be sure that our transaction has been added to the chain. Right now, we've only got 1. If I go into the Explorer, I'm not going to see my transaction. You can see that that has now updated to 2 block confirmations. And now we know that our transaction has been added to the chain. So now let's check. Let's take a look at it. Let's go into the Smart Contract Explorer and let's check that everything works correctly. So simply click on Open Explorer. Once you click on Open Explorer, you're going to be presented with 3 options where you can use to interact or explore your smart contract. We've got TZKT, we've got TZ Start, we've got BetterCallDev. You can actually also interact with our smart contract right here in the SmartPy IDE. But I prefer the experience on BetterCallDev, so let's go over to BetterCallDev. Click on BetterCallDev. Now here in BetterCallDev, which is a smart contract explorer, we can see that we've got a list of 5 players and their votes are all initialized to 0, just like we wanted to do. So now we've got two entry points. We've got the increased votes entry point and we've got the voters entry point, which is just a dummy entry point. Up here in increased votes, we can simply pass, let's say we pass 3, right? So we want to increase the votes for player ID 3. Come down here, click on execute, click on wallet, and that's going to load up the temple interface so that we can interact with our smart contracts using our wallet address. Click on confirm. And now we can see that the transaction has successfully been broadcasted to the network. Now we can actually check if everything worked correctly by going to storage. And as you can see, player 3's votes has increased by 1. That's how you write a very simple voting application as a smart contract and deploy it to the Tezos blockchain. In the next part of this series, we're going to use React as the front end of our application to write a dApp that connects to our voting smart contract that has now been deployed on the Tezos blockchain. See you next time.